So, good morning, guys. This is Anjani Kumar, dealing instrumentation subject for final year electrical students. I think all of our students are fine at their homes. Definitely, the COVID-19, how it is affecting the whole world that you are seeing from your web, newspaper, and all these things. So, be safe and make your surroundings also safe. So that's my words from my side. So you people definitely follow this thing, right? Definitely you should know how it will affect. So each and every person will affect. So if you don't follow this one, right? In the last session, we started a modulation, right? We discussed about what is a modulation, what is the need of a modulation, and what are the different types of a modulation that we discussed in the last session, right? Or I will repeat one more time. So what is a modulation? So modulation means high frequency signal is going to be combined with a low frequency signal in order to transfer signal for a large distances, right? So that process we can call it as a modulation, right? What is the need of a modulation? Means low frequency signal, if you want to transfer, the antenna should be very high. So the cost based issue, noise rejections, right? Disturbances are going to be avoided. Alright, all these things that we discussed. And what are the different types of a modulation? So modulation means my carrier signal is going to be modified, right, according to the instantaneous values of my message signal, that is my input signal. So my input signal won't change because that signal you have to transfer for a large distances. So that is combined to the high frequency signal. So according to that, my high frequency signal, carrier signal, will change. Alright, so that's a concept. What are the different types of a modulation? Means there are two types of modulation: continuous signal modulation and pulse modulation. Continuous signal modulation means, so whatever the carrier wave that you are using, so that is a continuous type, right? Whatever the carrier signal, if it is a pulse type, means a pulse modulation. So continuous type, which is having sinusoidal type. Sinusoidal means which is having a amplitude value, frequency value, phase value, right? So the modulation will be classified into amplitude modulation, frequency modulation, and phase modulation. Alright, so what is a pulse modulation? Pulse modulation, which is again classified into two types. So that is analog modulation and digital modulation. So analog modulation further classified into three types, like pulse width modulation, pulse time modulation, pulse position modulation, right? So these are the things. Now we are going to discuss about types, basic types. So there are the amplitude modulation, frequency modulation, phase modulation, that we are going to discuss here. Not that much important. Try to understand the basic thing. That's it, right? Right. So amplitude modulation. So that means you will say the definition, right? So what is amplitude modulation? So basically my carrier wave will change instantly in order to transfer for a large distance. My message, whatever the input signal, won't change. We'll say the definition. The amplitude of a carrier wave will change instantaneous value of my message signal. That means amplitude of my carrier wave will change accordingly with the instantaneous value of my input signal or a message signal. So that modulation we can call it as a amplitude modulation. Alright. So amplitude modulation means high frequency signal is going to be connected, high frequency signal is going to be combined. So after that combination, my amplitude of a high frequency signal will be changed. So those type of a modulation we can call it as a amplitude modulation. We'll see how it will happen. I'll clearly explain. See, this is the time axis. So this is my message signal. So this is called a message signal. So that is nothing but input signal or modulating signal. So this is low frequency signal, right? Now I have a carrier signal, so which is having high frequency. That means high frequency. So what is the carrier signal? Right? So this is a carrier signal, so which is high frequency signal. So that is nothing but high frequency signal. So you are going to be combined. So right, what is amplitude modulation? So while combining, so the amplitude of a carrier wave will change according to the instantaneous values of the input signal. Right? We'll see how it will be. I already told that my input signal won't change, only carrier signal will change. Right? How it will change, we'll see. Right? If you draw, right, my input signal, amplitude, frequency, whatever the signal won't change. So when you combine, my carrier signal will change and the resultant will be appear. So my input signal will be same shape is going to be same. Right? So from this, what happened? My amplitude of a carrier signal will change. So how the amplitude of a carrier signal will change, we'll see. The frequency won't be changed. Right? So that means you will see this is my input signal na? So my carrier signal which will be changed, the amplitude of a carrier signal will be changes, right? So the amplitude of a carrier signal will be changed only, not the frequency. So that modulation, when you combined this low frequency signal with high frequency signal, the amplitude of a carrier signal, see, the amplitude of a carrier signal will change according to my input signal. My input signal is a constant amplitude. So whatever the amplitude ikkada high ga undi, same amplitude we are getting. Ikkada high ga undi, increase avta undi, amplitude you get same amplitude reduces, amplitude again increases. So in this way you are getting the waveform. So this is called a modulated waveform. So I hope understand. So my carrier will change according to the instantaneous values of my input signal. So my input signal never change because that signal you have to transfer for a large distances, right? So when you combine, your carrier wave is going to be a type of a modulation, your carrier wave will be changed, right? So here, so what is this? My amplitude of a carrier wave will changes in order to transfer the large distance. So these type of modulation we can call it as an amplitude modulation. right? So this is called envelope, right? So this is called lower band, this is called upper band. So at any place you can take the message signal from this band also, you can take the message signal from this band also. Alright, so I hope it's clear. That means what is meant by amplitude modulation? My amplitude of a carrier wave will change so according to the instantaneous values of my input signal. So that process we can call it as a modulation. Right, now I am taking the message signal. So this is a message signal which is my input signal, which is a modulating signal. That signal we need to modulate and transfer. Right, so for this we require a high frequency signal. So this is my carrier wave signal. So this is the amplitude of a carrier signal. Right, and that if you know the time period, the frequency also know. That means what is amplitude modulation? Your carrier wave amplitude will be changed according to the input. So my input is constant, same. So my carrier wave amplitude will be changes in order to transfer for a large distance. So this type of modulation we can call it as an amplitude modulation. Now we'll go for frequency modulation. Right. Now we'll go for frequency modulation. What is a frequency modulation? So what is a frequency modulation? You will say the definition. That means the frequency of carrier wave will change according to instantaneous values of my input signal or a message signal. So this type of modulation we can call it as a frequency modulation. So that means the modulation means high frequency is going to be combined with a low frequency signal. So after that what happened? Your carrier wave frequency will be changed, but not the amplitude, not the phase. The frequency will be changed. So these modulation we can call it as a frequency modulation. I'll explain with figures itself. So first of all, you should know what is a frequency. Right, but suppose if you have a wave like this, right, so this one cycle, so we can call it as a time period. So this is one cycle. This cycle is going to be repeated. You already studied about a periodic signal and a periodic signal. So this is another cycle. So this is called another time period. This is another cycle. This is called another time period. So what is meant by frequency? Cycles per second. For per seconds, this is one cycle for a t seconds. So if per 1 second, how many cycles? So that represents the frequency. So frequency is equal to 1 by t. So if you know the time period, it is easier to find out the frequency of a signal. Right? Now we'll see. I have a message signal. Similarly, last examples also I'm taking. I have a message signal. Right? So this is time t. So this we can call it as a message signal or modulating signal. Right? Now, for a modulation, we require a carrier wave. So that is nothing but high frequency wave. We require a high frequency wave. Right? So this is the amplitude. So this we can call it as a carrier wave. Right? High frequency wave. Now you are combining this carrier wave with low frequency signal. right? I already told that. So frequency modulation means the frequency of this carrier wave changes according to my input signal. My input signal will never change. Now we'll see. Right. From here you will see my amplitude is going to, whatever the signal is going to be, increases, here decreases, here increases. In a similar manner, my frequency will be changed. Alright, in a similar manner, here the frequency is very less. After that, the frequency is going to be increases, then decreases and increases. The frequency increases means a time period is going to be reduces. If a time period reduces means signal is going to be, the duration of a time is duration of cycle is very less. So we'll see how it will be. So the time frequency is going to be increases up to this point. Here up to this point the frequency is going to be increases. That means time period is going to be very less. We'll see. But my amplitude never change. This amplitude is going to be constant. Right. So after that frequency is going to be reduces. The frequency reduces means some vast distance is going to be maintained. At this point the frequency is very less. So that means the frequency is very less. After that the frequency is going to be increases. Right? You will see. So here the frequency is going to be increases. Here the frequency is low. Here the frequency is going to be increases. That means the curve should be increases. Here it is going to be decreases. After that increases, right? We'll see here this portion my frequency is going to be increases. After that decreases. After that increases. That means increases, decreases and increases, but my amplitude never change. So if amplitude modulation, the amplitude is going to be changes, but my frequency is a constant. The frequency modulation, my frequency will be changes, but amplitude never change. Alright, so this is called a modulated signal. So that we need to transfer for a large distances. I hope it's clear what is a frequency modulation. So the frequency modulation means the frequency of a carrier wave will changes according to the instantaneous values of my input signal, but not the amplitude. If amplitude changes, that signal we can call it as amplitude modulation. If a frequency changes, then that is called a frequency modulation. Now I hope it's clear. Right, now we'll go for phase modulation. That means each and every continuous wave that it has some amplitude and phase and frequency. That's why the modulation have three types. That's the amplitude modulation, phase modulation and frequency modulation. Now we'll discuss phase modulation. First you define what is a phase. So what is a phase? Right. The phase is nothing but the position of a point at particular time instant. Correct? So what is meant by phase? The position of a point at particular time instant. So phase difference, and that means two different points. So what is a position? For suppose if you see my signal is right. So this is the first signal. So a sinusoidal signal 0, pi 2 pi. So this is pi by 2, this is 3 pi by 2. Right? This is the first wave. Right? So what is this phase? The position of a point. For suppose the phase is 0. Assuming that I have another wave. So which is started from here itself. So this is wave 2. You will see what is the phase difference, which one is lag and lead. So this wave will start here now, right? So this wave will start from here now. That means the second wave mundunda, first wave mundunda, the second wave mundundi. That means second wave leads first wave. That means first వచ్చేది ఏంది second wave, after that first wave. That means second wave leads the first wave. How much an angle? That phase angle. How much an angle? So this is 0, this much angle na. So what is that angle? Pi by 2. Leads by an angle pi by 2. Or else the first wave lags second wave by an angle pi by 2. So this is a phase difference. What is the phase difference for this one? 0 నుంచి pi by 2. So this is the phase difference for this one. That means ఏ వేవ్ ముందు వస్తుందో దాన్ని చెక్ చేసుకుంటే you will be easily say whether the signal is lagging or leading. Right? Here from see which one is first, second is first. That means second it lead by first. Or else first lag by second. How much angle? ఇది వచ్చేసి 0 నుంచి స్టార్ట్ అయింది, ఇది వచ్చేసి pi by 2 నుంచి స్టార్ట్ అయింది. So what is the phase difference? Pi by 2. Right? So that is a phase difference. Right? Now we'll discuss about phase modulation. Now we will see what is a phase modulation. The phase of a carrier wave will change according to the instant of input that you are going to be applying. So we'll see the phase will change, amplitude, frequency never change, the phase will change. Now we'll have a signal. So what is the input signal? So this is my input signal. So this is called message signal or else modulating signal. Alright? So I need a carrier signal. So which we need to transfer, we require a carrier signal. So what is that carrier signal? Which is a high frequency signal. Right? This is amplitude. Right? Now you have to change the position. So from where this will change? First you have to draw the point over here. Right? You will see. Right? From this portion, right, where the change occur from phase change occur from this portion, right? So this portion there is no change. I'll get the same amplitude, same frequency, same wave. Right? So after that your phase is going to be changes. So phase changes అయితే ఇక్కడ నుంచి ఎలా రావాలా, కిందకి రావాలా. బట్ you will get the change in phase from started from here itself. Right? Right? Okay. After that again the phase will be changed. Phase will be changed means ఇటు పోవాలి కదా, బట్ ఇటు పోదు, మళ్ళీ ఎటు వస్తుంది, ఇటు వస్తుంది. Right, again. So I hope it's clear. Right, is there anything? Nothing is there. But suppose, so this is a positive and this is a negative and this is a positive and this is a negative. Right, we'll see one more time. The phase difference means the phase of a carrier wave will change according to my instantaneous values of my input signal. So this is my input signal, sinusoidal input signal. So this is called a message signal or this is called a modulating signal. Right. So for this we require high frequency signal, so that we can call it as a carrier signal. Right. I require a carrier signal. Now where the phases are going to be changes. So from this point and again phase will be changed here and again phase will be changed here and again phase will be changed here. So my phase will be changes, right? So up to this portion, so this is similar, like this, like this, like this, like this. At this portion my phase will be changes. So changes means how this means itla రావాలి మామూలుగా. ఫేజ్ చేంజ్ ఏంటంటే ఇలా వస్తా, రిపీట్ రివర్స్లో వస్తుంది. దట్ మీన్స్ సో మై కర్వ్ స్టార్ట్స్ ఫ్రమ్ హియర్ ఇట్ సెల్ఫ్, రైట్, కిందకి రాకుండా పైనుంచి స్టార్ట్ అవుతుంది. మళ్ళీ ఇక్కడ ఫేజ్ స్టేట్ అయింది. యాక్చువల్గా పైకి పోవాలా, పైకి పోకుండా కింద నుంచి స్టార్ట్ అవుతుంది. దట్ మీన్స్ మై ఫేజ్ ఈజ్ గోయింగ్ టు బి చేంజెస్. జీరో నుంచి స్టార్ట్ అవుతుందా, పై బట్టి నుంచి స్టార్ట్ అవుతుందా, వాట్ ఎవర్ ఇట్ మే బి, ఈజ్ గోయింగ్ టు బి చేంజ్ ద ఫేజ్. దట్ మీన్స్ యాక్చువల్గా ఎలా ఉండాలి, క్యారియర్ వేవ్ ఎలా ఉండాలి, ఇక్కడ దాకా నో ప్రాబ్లం. సో ఫ్రమ్ హియర్ టు హియర్ ఇక్కడ వరకు నో ప్రాబ్లం. ఇక్కడ ఏమైంది, ఫేజ్ చేంజ్ అయింది మా ఇన్పుట్ వేవ్లో. నాకు క్యారియర్ వేవ్ ఏమో అలా చేంజ్ అవ్వాలి. చేంజ్ అవ్వాలంటే ఏం చేయాలా, నేను ఇక్కడి నుంచి రావాలి కదా, నా క్యారియర్ అలా రాదు, ఎందుకంటే ఫేజ్ ఈజ్ చేంజింగ్. దట్ మీన్స్ మై క్యారియర్ వేవ్ ఇస్ గోయింగ్ టు బి స్టార్టెడ్ ఫ్రమ్ అప్పర్వర్డ్స్ ఆన్వర్డ్స్. ఆఫ్టర్ దట్ హియర్ ఇక్కడ మళ్ళీ చేంజ్ అయింది, మళ్ళీ పైకి పోవాలా, బట్ పైకి పోవాలా, కింద నుంచే వస్తుంది. సో దట్ మీన్స్ మై ఫేజ్ ఈజ్ గోయింగ్ టు బి చేంజెస్, రివర్స్ ఫేజ్ అనమాట. పైన ఉండాల్సింది కింద ఉంటుంది, బికాస్ దిస్ ఈజ్ అ నెగటివ్, దిస్ ఈజ్ అ పాజిటివ్ అండ్ దిస్ ఈజ్ అ నెగటివ్. లైక్ దిస్ మై ఫేజ్ ఈజ్ గోయింగ్ టు బి చేంజెస్. సో దిస్ ఈజ్ కాల్డ్ అ మాడ్యులేటెడ్ సిగ్నల్. So this we can transfer. So from this we can easily identify. This is a positive, this is a negative, this is a positive, this is a negative. Right? Here itself, the positive and the negative, and the positive and the negative, like this. So this is about phase modulation itself. So in this session we discussed about 3 modulation techniques. What is the amplitude modulation, what is the phase modulation, what is a frequency modulation. What is amplitude modulation? When you compare a low frequency signal with high frequency signal, the phase of my carrier signal will be, my amplitude of my carrier signal in accordance with my input signal is going to be changes, right? My amplitude of a carrier wave will change according to the input, whatever the message signal it is. Frequency modulation means my frequency will be changed according to my input signal. Phase modulation means my phase will be changed. Phase, each and every time the carrier signal will change. My input signal will never change. The amplitude, whatever the shape and all these things are the same. My carrier will change in order to transfer the signal, right? I hope it's clear. If you have any doubts, feel free to ask me, because this is an electronic subject, right? But no problem. You just call me and ask any doubts regarding my subject. I'll definitely be ready to explain each and everything once again also. So thank you for now. We'll discuss what is a pulse code modulation, what is a samples, how we can take a continuous signal into discrete signal, and all these things we'll discuss in the next session. Thank you very much. Bye.